Hello, everybody, and welcome to another OpenShift Commons briefing. This time, Aporeto is going to talk about end-to-end security for microservices. We have Ariful Huq, who's the Director of Product Management. I'm going to let him introduce himself. The format, again, as always, is ask questions in the chat while the talk and the demo are going on, and then we'll have live Q&A at the end. And with that, I'll let Ariful take it away.
Hey, thank you, Diane, and thanks everybody for joining us this morning. My name is Ariful Huq. I run product management here at Aporeto, and what I'm going to talk to you about is end-to-end security for microservices, and I'm actually going to show you a demo towards the end as well. Okay, so what I want to start off the discussion is talk about sort of the shift that's happening from monolithic applications to cloud-native applications and how that is impacting security. So in the monolithic world, you typically have a single monolithic software running within the context of a data center. You have a perimeter firewall that's protecting that application, and that perimeter firewall typically is doing north-south protection, right? And then as you move towards a cloud-native world, what's happening is that monolithic application starts to become a distributed set of components. And these components can be on your on-prem data center, or they can be in the cloud as well. So right there's a few changes that have happened. The parameter is no longer within the context of your own data center any longer. The infrastructure over which your application is hosted may no longer be under your control, because if it's being hosted in a public cloud environment, you don't have control over that infrastructure. So there's a couple of things that are required, a number of things that are required or considerations that need to be taken as you make this transition. And since the parameter no longer exists, a distributed security model is required. So that's going to be the kind of the focus of discussion today as customers are making this transition from monolithic to cloud native, adopting cloud native services. What's kind of the security considerations required? So to start off, I'd like to discuss the security challenges as you make this journey. So we talked about cloud native, and one of the things about cloud native is they're dynamic in nature. What do I mean by this? Typically, when you want to make use of cloud-based infrastructure, you want to make them elastic. You spin up a host in your cloud infrastructure, and your application, deploy an application, you want that infrastructure to be elastic, based on demand. As you see demand increase, the infrastructure should be flexible where it grows as the demand increases. So that means the nature of deployment is actually a lot more dynamic. It's no longer a static deployment. It's no longer a virtual machine on a host. And the life of that virtual machine is quite long. Now it's a container on a host that may have a life of 1 day, 2 days, maybe a week, depending on how fast you actually go and deploy your applications. Now, this invalidates some existing security practices. What do we mean by this? What we mean is the traditional models of writing ACLs based on IP rules really becomes hard, because when you deploy containers in a dynamic environment, or when you deploy microservices in a dynamic environment, and you're deploying on a daily basis or even multiple times a day, the IP addresses will definitely change. So if you're writing rules based on IP addresses, those become extremely hard to manage. Even if you automated that entire process, the number of rules increase over time, and it's really kind of hard to figure out what those rules actually mean. So the deployment velocity also reduces, because if you're going to try and deploy these applications multiple times a day, typically what happens is your security teams get involved before that application gets deployed for compliance. And your security teams have to now figure out what IP addresses, update rules. So really the automated process of deployment is also hampered. And this is a big challenge. We talked about the fact that you no longer own the infrastructure. So this introduces new threat vectors, because your container is hosted on infrastructure that you may no longer own. So you need to get visibility at the host layer, right? You need to figure out what's happening, the interactions between your container and the underlying host. As well as when you deploy containers, what's the base image for that container, and what are the vulnerabilities associated to that container? You may choose a base image. Somebody built a container with a base image. Over time, you kept the same base image, but you didn't really figure out what are the new vulnerabilities associated to that new container, to that container. So that introduces a new kind of threat vector: identity, certificates, and secrets. This is important even in monolithic applications, but then as you head towards microservices, this becomes a lot more pronounced because you have a lot more application components. And the key to and we're going to talk about this in a lot more detail, the key to doing authentication and authorization is to assign identity. So assigning service identity becomes really, really critical, and doing this in massive scale becomes important. As distributing secrets, you don't want to have secrets within your application. So distributing these secrets across your applications also becomes important. Certificate rotation and certificate issuance, those are things that you also have to consider. Typically, what we see is developers spend a lot of time building this infrastructure as opposed to working on business logic. So they're trying to introduce new ways to distribute secrets and building a PKI infrastructure to manage certificates, and that takes some time away from business logic. So that work needs to be offloaded. And finally, the API is a new resource in microservices, and everything is controlled through this API. So how you access a microservice, what are the CRUD operations towards that microservice, is all controlled through an API. And authentication authorization for these APIs is extremely critical. What we typically see is customers try to do this authorization logic within their application. And that becomes really, really difficult because it becomes harder to manage. If you have a change in the authorization logic, it's hard to manage that change. You have to go deploy the application again. So these are the challenges that we see in the microservice world. And what we're going to talk about is some of the considerations you should take when approaching a security solution, given the challenges that we just talked about. So there's two things that at Aporeto we focus on. It's the fact that the solution must be based on the principles of zero trust security, and I'm going to explain this in a lot more detail. What do we mean by zero trust? The fact that you should assume that you're always under attack and no communication is permissible until you present the right identity. And number two is this concept of a heterogeneous environment. What we see is customers, when they deploy microservices, they do this across on-prem, cloud, and it has to take into account multiple types of environments. So we'll talk about that. So what do we mean by zero trust security through identity? So the core to any authentication authorization operation is presenting the right identity. I need to present my identity first before I authenticate this communication. And once I've presented my identity, then I'm able to authorize based on an existing policy. So we break it down in terms of kind of really two actors. One is the user, and the other is a service or an API endpoint exposed by that service. So the interaction points can be a user trying to access a service or an API endpoint exposed by that service, or it can be between two services. So when a service tries to initiate a connection with another service, it has to present a service identity. And what does that service identity mean? It can come in many ways, and it's contextual. So for instance, container metadata can be part of that service identity. What is the image information associated with this container? Is it running Mongo? Is it running Nginx? What's the build data? Did it pass regression? Did it pass the critical milestones that are required before this application should be deployed? All of these milestones can actually be embedded as metadata into your container through the deployment process. And you can extract this information when you deploy this container. What type of container is it? Is it a front end? Is it a back end? What type of vulnerabilities are associated with this container? We see customers do the vulnerability scans as part of the CI/CD pipeline, but once the container gets deployed, how do you have visibility in day two for what vulnerabilities are associated with this container? In day two, if there's a critical vulnerability associated to a container and it is a front-end container, you want to take remediation action. So having that vulnerability data be part of the contextual identity of the container is actually really, really critical. So this is what we mean by the identity of a container. you can extract this information and kind of use it as a fingerprint anytime it needs to communicate with another service or a user tries to communicate with it. And in terms of a user, the identity is some sort of a token that may have been issued by an identity provider, right? So an identity provider could be Okta or Auth0. You basically get authenticated and there's a token that's issued and you present that token. And that token allows you to authenticate, authorize the user to service communication. The heterogeneous environment, kind of what we mean here is the application in itself can be hosted across multiple environments. Here's one example that I like to bring up here is we were talking to one of our customers. They're building a loyalty program. And with microservices, what they realized is they have small teams and people can build their own functions using their own languages and their choice of a platform. This specific customer actually had, they were using AWS, they were using Azure, they were using microservices, they were using based on containers and virtual machines. They were using Azure Functions because one of their teams decided, hey, Azure Functions is actually going to work really well for what we want to do. So now you have a mixture of Lambda serverless functionality. You have service mesh technology that you'll be using on top of Kubernetes. You have Docker clusters. You have Linux services. How do you implement authentication authorization across all these technology stacks? Because it's important to do that. You need to have a centralized way to authenticate, authorize any sort of communication in this environment. And the environments themselves can be deployed across any IaaS or PaaS environment. So it can be deployed in AWS, Azure, OpenShift, in what we're going to talk about today, IBM Cloud or Google Cloud. So sort of any type of environment. So that's what we mean by heterogeneous environment, and the security solution needs to consider this. So taking those things into consideration, let's talk about what we're doing at Aporeto and some of the use cases. So I'll start off with use cases. So the first thing is service identity. With Aporeto, what we do is any sort of component, any application component, whether it be a container or a virtual machine, we assign it automatically. We assign it service identity. And how we assign it, we talked about this briefly. In the case of a container, we're able to extract a lot of metadata from this container and use that as the identity of that container. So when a container comes up, whether it's in a Docker environment or whether it's in a Kubernetes environment, we're able to inspect through the Docker API, through the Kube API, what is this container, validate that, and then assign an attested identity to that container, right? As part of identity, there's also certificate distribution because typically the identity is being assigned to a certificate. And you need to handle certificate rotation and revocation. Those are all things that we actually take care of. Segmentation and access control. So this is by far our biggest use case. Being able to do network segmentation. So you have kind of process to process or container to container, virtual machine to virtual machine level of segmentation, right? And this can be for compliance. It's just to reduce the scope of your threat vector, make sure that everything is authenticated, authorized before you allow the communication across any environment, whether the application is being deployed in a public cloud environment or whether it's being deployed in your own on-prem data center, doesn't matter. We will authenticate, authorize those communications. API level access control. So getting into the API level visibility, so I can give network level access between two containers or two pods, but that's not sufficient because given I have access between two pods, what are the API endpoints I should have access to? What are the API endpoints I'm authorized to have access to? That is the level of access control that we provide. Automated flow and telemetry logging. So being able to get visibility across your applications, the dependency map. So when an application initiates a connection, is it allowed? Is it denied? Across what are your dependencies across your application? What is this application talking to? Getting that level of visibility is extremely important. So that's something that we provide. Encryption. So being able to do service-to-service encryption using mutual TLS. This is extremely important because you don't want to integrate this into your application. If you have, that's fine. Then you don't have to use this capability. But if you haven't, having the burden of integrating TLS libraries into your application and setting up the PKI logic associated to that, so you can do certificate distribution, is very painful and a lot of work for developers. To offload that from your application. Vulnerability analysis, so being able to continuously monitor vulnerabilities within that container and notify the user that, hey, a new vulnerability has been introduced, a new critical vulnerability has been introduced, so you can assess the impact of that vulnerability. These are the 4 use cases that we focus on at Aporeto. So where does Aporeto fit? So where we fit is, if you think about a host, in the case of a simple bare metal virtual machine, we are a systemd process, an agent on that host. In the case of a Docker environment, we're another container on the Docker environment. In the case of Kubernetes, for example, in OpenShift, it's actually exactly the same as any other Kubernetes cluster. We're a daemon set, right? So you bring us up as a daemon set in that environment. We operate on top of any infrastructure, so it doesn't really matter where your OpenShift cluster or where your application may reside. It can be on any public cloud or private cloud environment. We also work with, if you're making use of kind of Linux processes, the automation mechanism can be done through Chef, Puppet. So multiple ways to kind of bring up our solution. So there's an enforcement point or an agent that's on the host, and then there's what we call the Aporeto Security Orchestrator, which is your single pane of glass into the Aporeto solution. It is what you use to get visibility. It is what you use to go define policies, and it allows you to do everything that you need to manage this entire solution through a SaaS platform. The SaaS platform in itself can be single-tenant or multi-tenant, depending on sort of the user preference. The platform also has access to third-party things like, for instance, vulnerability scanners. So we are able to kind of tie into a Qualys or Tenable vulnerability scanner that you may be using. So because you have that in your environment, we're able to kind of extract the information from those vulnerability scanners and use that to enforce stronger policy in our environment. Tying into a SIEM environment, security incident management tool. So being able to tie into a Splunk or a Curator or ArcSight. Tying into a CI/CD pipeline. So we talked about the fact that you can get a lot of rich data on the life of a container. So as it went through the deployment process, did it pass regression? Who committed the code that resulted in this container actually being built? Getting that information and being able to enact policy based on that is actually very important. So we can tie into GitHub to get all that kind of information. And then kind of connecting to cloud APIs like AWS. In the case of AWS, what we're able to do is figure out what are the AWS managed services that you're using, and actually give you access control to managed services. So for instance, your server needs to talk to a DynamoDB. So DynamoDB will show up as an external sort of service managed by AWS, and you can enforce policy should the server have access to this DynamoDB database. Okay, so how does this solution actually work? So I'll kind of walk you through from the beginning. So what happens is there's an enforcer that comes up on a host, again, as a daemon set or as a container or as an agent. It goes through a registration process. And as part of this registration process, it gets an identity itself, right? So it's an identity that we actually assign to the enforcer that has root trust through a certificate root authority that's on the Aporeto orchestrator, or we can be an intermediate certificate authority as well. So if you want to use your own CAS, that's completely fine. Once that happens, the application comes up, and we assign an identity to this application, right? So there's an attested identity that's assigned to this application once the application comes up. And once that happens, we get the policy for this specific application. What are the authorization rules for this specific application? And then the application tries to initiate a connection. And this is a three-way handshake, a sense, and I can act. As part of that three-way handshake, we authenticate and authorize this interaction with a service identity. So the application has to present its service identity to its remote endpoint we authenticate authorized based on the service identity, and only then we allow this connection to go through. Once the connection goes through, we actually get out of the path. So we are only in the path for the three-way handshake. Now, if you want us to do encryption, then certainly we have to be in the data path for the encryption piece. But if you don't want if we're not enabling encryption, then all we're doing is looking at the three-way handshake, embedding the service identity, authenticating, authorizing that communication, and then we're out of the path. Now, with API level access control, it's slightly different. It's the same process, but once the FinFin is complete, the TCP level negotiation is complete. Again, we're doing that based on service identity. Then what we do is there's an HTTP request that's made. Right now, we're doing REST-based services. That's kind of what we're focusing on for the API level access control. We'll extend this to Kafka and gRPC as well. So once the HTTP request comes in, we actually insert service identity and claims to this request through the HTTP header as a token. And this identity and claim is presented, and then only then you have access to the specific HTTP endpoint, the specific API endpoint that you want to have access to, right? So it's just another level of access control that you have beyond just the TCP connection. We're actually doing it at the HTTP layer as well. So that kind of concludes the presentation. So I'm actually going to start going through a demo for this. So this is the environment. So,
and give it a second because we're not seeing the demo environment yet.
Oh, you're not?
There we are.
Okay.
It's here now.
Oh, okay, cool.
It works.
So what you're looking at here, and I'm going to switch screens here real quick. What you're looking at here is what we call the Aporeto security orchestrator. So I'm going to let this load for a second. So there's a few things that I want to highlight. So this, again, this is a SaaS-based service. We have this concept of a namespace, and this is important to highlight early in the discussion because this is sort of how you control access and how you define policies and who you give access to this controller. So the concept of namespace allows you to kind of build isolated environments. So my name is Ariful Huq. I have a dev, a prod, and a test environment. But think of this as a company that has multiple business units. And each business unit is given its own namespace. And within that namespace, they have a dev, a prod, and a test environment. And these environments are completely isolated, right? So right there, you've completely isolated these environments and without having to even write a policy, right? So you've kind of created an isolated namespace and you start to deploy these applications. Now, if you need to talk between namespaces, certainly you can write policies that will allow you to do that. And we'll actually show you that as well. Now, for instance, in my case, within my prod environment, I have multiple kind of environments in itself. Like I have multiple clusters some that are deployed in AWS, some that are deployed using OpenShift. So I basically have created within my prod environment multiple clusters, and within one of those clusters, I have an application that's deployed, right? So this concept of a namespace allows you to create hierarchy. So your information security team can essentially write policies at a very top level hierarchy and say, I want all communications between pods or between containers to be encrypted. That can be a very, very high level policy construct that gets propagated down to every single organization, right? So your information security team can enforce that policy. Now, as you go further down the organization, as you go into a prod environment, as your DevOps team are deploying these applications, they automatically inherit this policy, and they can write their own policies, not having to worry about the overarching policies that the company enforces, right? So that's the environment. And then this is sort of your single pane of glass into the solution. So I'm going to kind of demonstrate this to you through an app. It's a very simple app called Bookinfo. You might have actually seen this a number of times. A lot of people use this app nowadays. So this environment, what I'm showing you here is our containers, right? So this is the application itself consists of multiple microservices. So it consists of a details microservice, a product page, a ratings, and a reviews page. These are all individual microservices. And when I click on a specific microservice, in this case, a container, I can actually start to get the metadata associated with this container. And this is what we mean by the contextual identity of this container. So for instance, this container happens to be deployed on a host. It is deployed in an OpenShift cluster, and it's deployed in Amazon. And in this case, I can actually start to get information around what AMI, what availability zone in Amazon is it hosted on, what actual host is it residing on, what's the type of host, which region. There's a lot of information that we're starting to extract right from Amazon, and you can build policy on that. All of these are key value pairs that you can use to write policy. There's user-defined tags. So for instance, I've assigned app equals details. So this is a details page app. And so that's kind of the user identity. There's also vulnerability data associated with this container, and this is the contextual identity that we were referring to. So this container happens to have a number of vulnerabilities associated to it, and you can write policies based on that. You can say, if I have a critical vulnerability and it's a front-end container, alert me that in fact, there is a front-end container that has a critical vulnerability. You can say things like log connections. You can say things like don't authorize communications after a specific period of time. So we have this capability where you can say, if a critical vulnerability is on a container for more than a specific period of time, then disallow communication with this container. So it gives your teams some time to actually go remediate the scenario. So you don't have to, disallow communications or enforce a strong policy immediately. Give your team some time before that happens. So that's kind of contextual identity of that container. And these containers, these applications can be deployed across multiple environments, right? So part of my cluster is in AWS, part of it is it can be across multiple AWS regions. It could be in US West, it could be in US East. It doesn't really matter, right? The application in itself can be deployed across multiple clouds, across multiple cloud regions. And more importantly, it can work across a load balancer, it can work across a NAT gateway. It doesn't really matter to us because what we're doing is using the contextual or service identity to authenticate authorized communications. We're not looking at IP addresses. One other thing here is the fact that we don't even care about the IP address, so it can be overlapping IP addresses as well. This is an interesting point. In a lot of large companies, they tend to have overlapping IP addresses because teams are deploying applications and they're not aware that there's an overlapping IP range there, right? So what I'm going to do is I'm going to interact with this app a little bit just to show you what actually happens. So I'm going to come in here, do a refresh, and as I do that, you start to see connections start to show up. So what just happened here, and so we're giving you real-time visibility into all the interactions that happen as a result of me just interacting with that app. So I came in from the internet. I came into what you saw as the product page. From the product page, I went to a secondary page. I went to this details and reviews page. And as a result of that, the product page made a call to the details page. And the details also made a call to reviews because the review showed up in that page as well. And I'm going to increase my time frame here so it's easier to kind of walk you through this. So the product page made a call to reviews, as well as reviews made a call to ratings. So you're seeing, as I interacted with the app, a real-time visibility into all these interactions across any environment, across any cloud, right? Now, let's click on one of these interactions. And what I can see is there's the reason why this interaction was allowed is because there was a policy associated to that, right? So, and a policy is very, very simple. Policy here is if app equals product page wants to talk to app equals reviews or app equals details, accept that traffic, encrypt it, and log and source that destination. That's the policy. And you can define this policy in a number of ways. You can define it through our product through the wizard. You can define it as in a declarative manner through a YAML file, because that's what we realize people want to do now as far as the DevOps process. The DevOps engineer wants to automate the deployment of the policies. So you can certainly do that in a declarative manner through a YAML file as well. So that was the policy associated, the fact that we allowed that connection to happen. Now, we can also get some information as to, this was a gRPC connection, what type of connection it was as well. If you're coming in from the internet, for instance, if you're accessing an external service, like in this case, I've enabled UDP because service discovery is happening through DNS, and I need to enable UDP. So I will tell you what's the IP address it's actually it's using for DNS, right? So let's look at the policies that were implemented as a result of this interaction being allowed. So I'm going to go back to my network policies here. And so I allowed UDP. So essentially, my Apple's product details, reviews, ratings all have access to a service DNS. And I define the service as an external service because I'm not controlling this DNS service, but I can show you, we'll show you how we're providing access to this DNS service. I'm allowing connections from the internet. So the fact that the internet connection was allowed, that's the policy associated with that. And then the product page accessing reviews and details, this is the policy, right? So if I want to modify this policy, all I have to do here is look at the source, go in here. Again, it's a key value pair. I can assign another key value pair to it. Go into the destination. Destination is application review page or details. Action is to allow encrypt. Those are the actions that can be allowed. So what happens if I actually turn off one of these? Actually, so what I'm going to do is I'm going to turn off one of my policies here. So just to show you also the scenario where if I don't have a policy, what actually happens. So I'm trying to access this page. Obviously, it's taking some time because I actually didn't allow the details page. I didn't allow product to details page. So what will happen now is you'll see that I tried to communicate from the internet to product page, and it tried to initiate a connection towards details, and you see it in a dotted line. The reason why it's in a dotted line is because I actually have something enabled called design mode. And what design mode allows us to do is say that I don't understand my application interactions. Tell me what are the interactions so I can enforce policy, right? So in this case, because I didn't have a policy and I had this design mode enabled, what I did was I actually allowed that, I didn't allow it, and I told you that, hey, there's actually a policy that needs to be associated to this. I'll turn off design mode, and you'll see that when I disable design mode and I try to do this again, that the connection won't actually be allowed. And in this case, you see the connection is denied because there is no policy associated to it, right? So that's the policy structure is very, very simple in terms of how it gets implemented and how it's enforced. You define all the policies through the orchestration tool, and it's all enforced in a highly distributed fashion across your applications. So there's also another part of the demo related to APIs. So I'm actually going to just switch my namespace here so I can show you from an API perspective. What I just showed you was all at the network layer. Now, at the API layer, what we're able to do is actually, typically what happens is the developer defines an API spec. And the API spec says these are the APIs exposed by a specific microservice. And what I'm going to be able to do here is take this API spec, which can be a YAML, or it can be a Swagger file. We take the Swagger file and we take the inputs from the Swagger file as the API spec. right? And then we define services. In this case, I have a very simple app, and the app is what we call an Apple Wine app. It has a server, it has a MongoDB database, and a UI element. And what I'll do is now I will define the specific services for my microservice, and I'll apply the API spec to these microservices, and I'll apply a policy. And the way a policy is applied is using this concept of a scope. So I assign a scope to a specific container or service and say, you have these specific privileges, right? So for instance, in this case, I have this app, which is called a beer getter and a wine getter, and it has a specific scope. It presents the scope and it has access to what it needs to access. I have a UI app and it's given a specific scope. It presents the scope and it's given the access that it needs. In the API spec, what you can do is you can actually define these scopes. So for instance, in the internal APIs, you can see that if I want to get to a beer API, I have to present the default scope. If I want to get the wine API, I have to present the protected scope with a specific data organization. So for instance, we can even look at if a user is trying to access this specific API, which organization is this user from, right? We can actually look into the token that was issued by the IDP, look at the claims from that token, and determine should this user have access to this API. So not only are we enforcing policy at the network layer, but we're actually doing it as well as at the API layer through API level access control in our product. That's sort of the end of the demo, and I've accomplished everything that I actually wanted to show at the product, Diane. So I'm actually going to switch back to
this. Yeah, that would be great.
Yeah.
Wow.
So,
So you've done an amazing job covering off all of that. That was a lot. And the real-time aspect of it is pretty awesome. And I'm wondering, the one question I have is around the audit processing, because I think in the activity logs and things like that, is there, if you could pop back into the demo just for a second and go into the activity logs, as someone who's been in IT audit and stuff, I think that's kind of one of the things too, is being able to have those audit logs available. And to me, that's one of the keys to having this be really useful.
That's
offer.
correct. Yes, that's exactly right. So I did skip this, but yes, we are able to show you sort of anytime a policy changes happened, we're able to audit these interactions with the product. So who changed the policy? Why was this policy changed? So you have auditability into sort of policy changes. Also, you have auditability within the product for any sort of interaction that's happening, right? So when I showed you that specific, let's go back to a namespace here. Go into a specific. So we have this ability to actually look back in time. So over the last hour or over the last 12 hours or a day or a week, what are the interactions for the specific application? So you have visibility over time, what happened actually, right? What were the interactions? So we have visibility into even over the flows between the interactions between these specific applications.
So for me, I mean, I come a long time ago from an audit and IT compliance background. So these things are really important from, the compliance and the regulatory possibility, but it's also an amazing tool if you're trying to figure out how to track down, something that's gone catastrophically wrong, or try and track down these things. It's really, it's not just for the auditors. This is, really fun. Wonderful UI, first of all, so that I'm not just looking at log files. And it's really a great visualization tool for all of that information. So kudos to you guys for making this a reality and available, especially.
Yeah. And the other thing we also do, and I skipped the API piece, is auditability from an API perspective. So you can actually see what APIs were accessed by a specific client and why it was denied. So for instance, if it was denied, a rationale for why it was denied, who accessed this API, what were the claims associated with this API. So we have visibility at the API layer as well, sort of what are the interactions. Yep.
Yeah. This is, this is in some ways a dream tool for somebody like me that likes to dive in and figure out, where it went wrong or who did it, and the whodunit piece of IT
Yep.
and ops. So that's pretty cool. So I don't see any other questions from the folks in chat. I think you've done an awesome job covering off the topic and showing off this. So yeah, so show us how we get a hold of you and how to try it.
Thank you. So we have a bunch of collateral on our website, so I encourage you to go through. We have some white papers. We have some, kind of best practices around microservices and what are the things that we're doing. We have a try it now, so essentially you can just come in and register. So it's very easy to get started. Essentially, all you need to do is we have a console. You basically create an account. We permit you to get that account, and then once you have that, all you need to do is bring up the enforcement technology on the host, which can be a Linux process or a Kubernetes daemon set, right? In the case of Kubernetes, we actually even generate the YAML files that you need to deploy the daemon set in your environment. So once you define a cluster in our environment, you get a bunch of YAML files, just deploy them in your Kubernetes cluster in OpenShift, and you have the ability to do access control for all your microservices within that environment.
Well, very cool. Thank you very much for taking the time today to talk to us about this, and hopefully we'll get to see some of this in action soon at some of our production deployments, and get some more feedback from some customers for you. And if anyone has any questions, please do reach out. I know there's a number of folks from Aporeto who are in the Slack channel, and also available if you just ping them. I know they have chat on their website, so I've seen that pop up a few times. So please do reach out, and thanks again.
Thank you, Diane.